Hey guys, I know we haven't done this in a while, but this is a video which y'all are going to watch at home. You're going to fill in the notes, which I'm posting on Blackbaud, and I'll send you an email, and they'll be everywhere attached to the assignment. You'll hand in those notes, and there will be work for us. We'll be doing practice stuff during class time. This is like a kind of a one-time deal where I'm going to flip and do the video and then class and then homework in class. So this will be your homework. If you're in blocks 2 and 3, it'll be due Monday, the 11th, and if you're in block 7, it'll be due on the 12th, which is a Tuesday. So, anyways, let's get into it. This is our first, maybe, I don't know if you have or not ever seen them before, time talking about logarithms, which are very closely related to exponential functions. So, something that looks like this is called an exponential function. That's when the variable is in the exponent. That's different from this, where the variable is raised to an exponent. This is called a power function or a polynomial. Usually power is the word, and then this is exponential. But either way, no matter what it is, if there's an x and a y, we can graph it. So if I plug in 1 for x, let me write a little table here. If I plug in a 1 for x, I get 2 to the first for f of x, which is 2. So the point 1, 2 is on this graph. I plug in 2 for x, I get 2 to the second, which is 4 for f of x. Points. It kind of looks like a straight line right now, but if I maybe think, well, what if I plugged in 0? Can I plug in 0? Yeah, 2 to the 0 is equal to 1. Many of you are probably thinking 2 to the 0 equals 0 when I said that, and that is incorrect. Anything raised to the 0 power, any number raised to the 0 power is equal to 1. With the exception of 0. 0 to the 0 is not defined. So 0, when x is 0, y is 1. We get here. So now it's like not quite a line. It almost maybe looks like a parabola right now. So maybe let's check and see what happens at -1. Right, if that one goes back up here, I'd be confident that it would look like a parabola. See, 2 to the -1. Well, 2 to the -1, you may recall, is equal to 1 over 2 to the 1, which is just 1 over 2. That's just 1/2. The negative exponent, you put the base on the bottom and raise it to the positive power. So 1 over 2 to the 1 is 1/2. So actually, so this is clearly not a parabola. Otherwise, it would have gone back up. If I put in a -2, just for a laugh, I get this kind of same deal here, but I have 1 over 2. The positive power is now +2, which is 1 over 4. And that's like going to be down here or something. And the idea is that if you kept doing this, these would get closer and closer to 0 because this power would get bigger and bigger. And these numbers up here would get larger and larger, closer to infinity. So this thing kind of has this curved thing going on like this. I did kind of a bad job drawing it down here, but the idea is that it gets very, very close to 0. And it does pretty quickly. It's like it's very, very small. It's like always getting closer and closer to 0. It's kind of hard to draw. And this gets big very quickly. In recent days, we've seen in the news maybe curves that look like this related to like numbers of cases maybe. So it's called exponential curve. And you may have seen this before. But the point of this was to get into these, which is to talk about these logarithmic functions. And just as a very brief preview of the graph, if I wanted to think about this as this function, this f of x here was 2 to the x. If I want to think about log, this is called log base 2 of x. So you're like, what the hell is this log thing? Well, it's a function and it's the inverse of the exponent. So what that means is you're going to switch the x's and the y's if you want to graph it. So where this one had the point 1, 2 on it, this one's going to have the point 2, 1 on it. And then 4, 2, and 1, 0, and 1/2, -1, and 1/4, -2. So it's a little weird the way these are written, but I'll start with the smallest and go to the biggest. The smallest is 1/4, and that's -2. And then 1/2 is -1. And then 1 is 0. And then 1x is 2, I should get 1. 1x is 4, I should get 2. So to get from here to here, you switch the x's and the y's. Now this picture, well, if I could draw it better, but you kind of get it, it looks like that. And this is like, so this is what we call the exponential function, this black line. This red line here is called the logarithmic function, and it's just the inverse of the exponent. So it's like the opposite. It's like it undoes the exponent. So we'll talk more about what that means to undo it as we move on, but I'm going to show you what this is going to mean and what's called, well, I think of it as a definition of the logarithm right here. Okay. So I'll read this because it's important, and I know it's important because it says right here, this is the most important thing ever when dealing with logs. That means logarithms. I literally cannot overestimate how much I want you to know this. This is going to show up on every test, quiz, homework assignment. It's going to be like the thing that's the most important about logarithms. So I would say log base A. See how that's like a little a, and then of B. You have that, like the B is like the same size as the log. It's like this is like a subscript, the A, and the B is like a normal size. So if I have log base A of B equal to C, that is exactly the same thing as saying A to the C equals B. I'm pausing here for a moment to let that sink in, how important that is. It's like real important. A to the C equals B. And we can talk in class about why this logarithm is an important thing. But the idea really is that it's sometimes hard to find this. Sometimes if you're like, what's the exponent? It's hard to know. And the logarithm is equal to the exponent. So if you can figure out the value of this, you can figure out what C is. And that's kind of the point of these. But it's not that important that you know that today. Let me give you an example of how this works. If log base 2 of 8 equals 3, well, it's not really if, it does. I'm just going to start that over. Log base 2 of 8 equals 3 because 2 to the third equals 8. The base, so like the little number to the what it's equal to, was equal to the thing inside there. 2 to the third equals 8. This little number here is called the base. The thing inside there is called the argument. That's kind of a mathy word, but that's what it's called. So just so we have the idea of the anatomy of this thing, there's the word log, and then there's a base that goes in this box down here. Then there's something that goes in here. There's like 2 blanks here, okay? And like you can never have a log without an argument. It's just not a thing that happens ever. It's like having a plus sign by itself, like 3 plus and then nothing after it. Like, you know, something has to go here. So like 3 plus what? So it's like, if you just have the word log, it's no good. In the same sense, and for the same reason, I guess, you can never divide by log. Like if I have log 3 over log 2, that does not equal 3 over 2. You can't cross this off. It's like crossing off a plus sign. The log is like an operator. It's like a thing that does stuff. It's not a number. It's not 3 variables multiplied. It's like its own thing. And it must have an argument. Must have this. You cannot just have a log by itself. I cannot emphasize that enough. Okay, cannot just have a log by itself. So one thing I can ask you to do is switch from exponential form to logarithmic form and vice versa. So if you want to like go back and reference this, like base A to the C equals B means this is true. Now this slide here is asking you to go the other direction. So I know that the exponent is going to be where it's equal to, and I know that this goes in the bottom. So 2 of 8 equals 3. You can check 2 to the third equals 8. 2 to the third equals 8. That's how this works. This one's going to be very similar. Log base 2 of 16 is equal to 4. 2 to the 4th equals 16. And you notice the base is always small and the argument is always sitting there inside the log, okay? Log base 2 of 2 is equal to 1. It's interesting, might be something to think about later. Log base 2 of 1 equals 0. 2 to 0 equals 1, that's true. Think about that one later too. Log base 2 of a half is equal to -1. That's true. And this one has just like letters and stuff in it, but that's fine. I can still do the same thing. 2 to this equals that, so log base 2 of n is equal to k. So that's how logarithms work. Like I said, this rule here is the most fundamental of the rules. So if you know anything at all about logs when you leave here, I hope it's this. Okay. I'm going to break this video. I'm not exactly sure how long it's been. I don't think it's been that long, but I want to make sure that they don't get too long. The next one should be a little quicker. So stay tuned.